Another day, another video. First of all, I'd like to apologize for the lack of updates. I've been writing a book on React, Node, and GraphQL, and it's taken up a lot of my time. I'm hoping it's going to be ready before the end of the year, and since I'm pretty close to finish now, I'm going to start getting back on the videos. So if you have any questions on this video or any of my other previous videos, feel free to ask questions on my website, dzhaven.com, and I will answer them there. So today's video is going to be about SwiftUI State Management. And the reason why I have this React application visible is because I want to compare and contrast React to SwiftUI. I think that there's a lot of parallels between the two. They're both reactive systems and state-driven systems. So if you already know React, becoming aware of these similar sort of patterns in SwiftUI, I think will help you learn SwiftUI a little bit faster. So before getting started with the state management stuff, we have to make sure that we are aware of a couple of things. So in SwiftUI, everything is basically a view, and every view is a struct. So even when you see text or VStack, they're all views and they're all structs. So the ramification of that is that it's immutable. So if you just use a regular field of any struct, whether it's a view or not, you will not be able to modify it. So if I try to modify this, I'll get an error that self is immutable. Now this is going to be true even if I use a reference type field, because ultimately it still lives inside of a struct. And if you think about it in terms of reference types, even when they have fields that are value types, because they are contained inside of a reference type, it still has reference-like behavior. So I think this totally makes sense and is consistent. So that's one thing to keep in mind while we're going through this. The other thing to keep in mind is to be very clear on how the rendering is being triggered in SwiftUI. So in order to show that, I'm going to use our first state type. So we'll use this this observable reloader object that I created. So what I'm doing is every time this increment button is clicked, it's going to increment the count and then it's going to display. Now obviously this is local state to this specific view. this property wrapper is not only going to make the view re-render, but it's going to allow us to make modifications to this variable, although seemingly it is a part of content view. So you could say that in a sense it's not, because it's really just a link to some other place in memory managed by SwiftUI. But this is why we are able to do this modification, whereas in this case we were not. So in order to better show the rendering, I'm going to pass this object wholesale to the child. Actually, I need to add its own timestamp. And I'm going to use this custom date formatter that I created. It's just so that I get a shortened timestamp. So this guy will have its own increment button. And it will also increment. Let's put this on top. So I just want to make clear, this is not an instance of this child. It's being passed in wholesale, meaning the entire instance. So this state is owned by and belongs to this parent view. So then, as you can see, when the screen loads, they're both having the same timestamp. But when I click, you notice that although the shared state is being updated together, which is what you would expect, you notice that the timestamp only for the child is the one that changes and the parent doesn't. So if I go to the child's button, again, nothing happens to the timestamp on the parent, even though its state was modified, and only the timestamp on the child is being updated along with the state value for count. So what's going on here? So the way rendering works is a re-render triggered by some state object is the only thing it does is it triggers that parent view's body property. That's it. So if that's the case, that it makes sense that the parent's timestamp does not change. It would just get set once during initialization and never be modified again just because its local state had changed, and only the count number would need to be updated, right? But how does that explain the child? So when the property is called, whenever it's called, whether it's the first time or whichever time, it is actually doing a reinitialization, a destruction and a recreation of everything inside of it. So therefore, when you click on the increment button, this is being called and a new instance of the child is being created. So that means every single time this is being set. And that's why we're seeing the timestamp get updated. And it doesn't matter if the trigger of the state change, again, this is not belonging to this child, it's belonging to the parent. It doesn't matter if the trigger for the state change is coming from the child. Even if it is, the state change itself is happening to the parent, and SwiftUI knows that. So the only thing that's happening is the body property is being called again, which again triggers a new initialization for the child view, which then triggers the created on date to be reset. So this might seem weird, but it's actually not, because it's exactly the way that React works. In React, you have local state. In this case, I'm using a reducer, but obviously you can use state. And there is a single object with multiple members inside of it. And one of them happens to be task list, and it's passed on to the view and all of that. But the renderer is really this return call, right? In the case of a functional functional component, right? But in the case of a class component, it would be the render function. But either way, when state is modified via a new payload, in the case of a reducer, that will automatically trigger React, the system, to call either the return for a functional component or render for a class component. So in the same way, pretty much exactly the same thing is happening in the case of SwiftUI. It's not that a render always triggers a reinitialization of the view. It's that it triggers the body property, and if the view is living inside of the, or defined inside of the body property, then it will get reinitialized. Just wanted to make that clear. Okay, so in order to make that clear, we introduced the observed object, which is based on reference types. And the way this works is, as you can see, you have to inherit from observable object, and whatever that you want to trigger a re-render, again a call of body in the view, you have to mark with this published property wrapper. So as long as you do that, and then when you create your instance, it is wrapped in the observed object property wrapper, then SwiftUI, the runtime, is going to know what to do. So in that sense, you could almost consider these things sort of shortcuts to eliminate some boilerplate code with Swift Combine and stuff like that. But regardless, SwiftUI will take care of the notification that will trigger this body render call. So then, if I were to give this guy, the child, its own view, its own state, and I did not pass it down, what would happen? So again, because the two are not tied, this guy has its own instance, this guy has its own instance, you can see that it only impacts the count text for the parent. But again, because body is called, it gets reinitialized and the timestamp changes. But when it gets reinitialized, it just means that it gets set to new memory, which is always defaulted to 0, and therefore this is 0. Vice versa, if I hit the child, it doesn't affect the parent because the child has its own state. Okay, but here is an issue. So what's going on here? So this child has its own instance, and therefore if it is reinitialized, this will be reset, which means that it will be reset to 0, right? So that is a problem if you want to maintain this child's count number independently, regardless of how many reinitializations happen. So in SwiftUI 2.0, there's a new property wrapper called State Object that allows not only all of the functionality pub sub of an observable object to be used and maintained by SwiftUI, but also SwiftUI will keep this object residing somewhere in memory out there and keep it alive even if this view is destroyed and recreated. So if I come here, it's maintained. So that is a way of maintaining the usage of a reference type and still be able to get the variable to stay alive in between refreshes that will trigger a reinitialization. All right, so what if my child doesn't need, let's pretend for a moment that I have 6 or 10 or 15 different members in here. And what if my child doesn't need the whole thing? They just need one field, let's say, in this case, count. So what I can do is I can use binding or the binding property to receive the desired field from the parent and show it or modify it. So before I show you, so like I was saying before, you have a reducer. It's a whole object, but it has multiple members in it. So if I take this and I want to use it in my task generator, then I can pass it in as a property, a prop, and then it will receive it and do whatever with it. Now in the case of React, these are one-sided or one-direction relationships, meaning that the child component should not be able to modify the sent in prop, but nevertheless, this is how the child can use simpler field values from the parent. Similarly, you can do the same thing with binding, but binding relationships are two-way. Therefore, if the child wants to make a change, they can. And I'll show that here. So they're sharing the same count. So they both go up. And again, the child is able to update as well. So they both go up even though it's the child's button. So this is what binding is. All right, so these are all these activities, all these state management activities are being done with reference types, but of course I don't have to use only reference types. I can use a struct type, and I can have, multiple members in here as well. And just like I did before, I can share it with binding without any issues. So if I run this, the net effect is going to be the same. Since they're both sharing, they're both able to increment, and they're both able to display the latest value. So then I have this capability for value types. When do I use which one? When do I use state versus either state object or observed object? So most of the time you would want to use a struct, meaning you would want to use something like this. The times you want to be wary is for performance, because sometimes you will be passing these in, and they will, because they're value types, they will get copied over when you pass them in as parameters. So in the case of a reference type, let's say it's very large. Let's say that there's a collection member in there, and it could get data from a network and have 50,000 records. You wouldn't want that sort of thing to be being copied every time it's being passed down some complex view hierarchy. So in that sort of situation, you would prefer to use a reference type. In addition to that, if you're passing these down and you, like how we did it in the initial example where this guy was an observed object, but it was just taking the reference from the parent. So, and you wanted to make that association, then in that case, obviously, you would want to pass by reference, because you wouldn't want to get a copy and end up, not getting the update. Now, when you're doing data binding, it doesn't matter, because SwiftUI is going to be, doing the link and doing the updating and all of that stuff. But I don't think that internally it is not doing a copy somewhere in that code path, because ultimately, if you do use state and you do use a value type, it's going to get copied somewhere in that chain. So I think for those types of situations, you're better off using either a reference type for performance reasons, or a reference type because you're not using binding, and you want to have that direct link to any changes that might occur. Okay, so In some situations, this sort of wrapper is inefficient. Because, for example, if I have a really complex UI, and then I have this child, and this child has another child, and that other child has various other children, and so on and so forth, having to bind with all of these, whether it's this or this, can be cumbersome. So there is a higher level property wrapper that you can use, and basically it acts as a global store. It acts very similarly to where is it? To React Context, in the sense that you can place the context provider at any level that you want. You could go ahead and place it at the very root. So that would look like so then, assuming you wanted to pass it all the way down the chain, this is what it would look like. You would just have to put it at the highest level that you wanted to, and then anywhere down that chain, you would simply use this, or how should I say, not instantiate, but declare this, and without having to actually pass it down manually, just like in the case of context, you don't have to pass it down through props or anything. You just use it. In a very similar way, you would do the same thing. So even here, I haven't passed it down through props. Through parameters. I've passed it down once globally. So if I wanted to, I could do that. So I'm just saying that it doesn't have to be at the absolute root. It could be somewhere in the middle. But the main benefit is I'm not having to deal with parameter passing or binding or complex binding. Okay, so let me unwind this. So, okay, so then what's next? Well, you have at environment. Let's get rid of all of this. So at environment is a lot like having environment variables. So, but they're specific to the Swift application runtime. And in here, there could be variables that are sort of global to any application. So, for example, so there's pre-existing environment variables, just like there would be, in Mac or Windows systems. But there's also the ability to create your own environment variables. And these environment variables, another benefit is that they're type safe. So it's honestly cumbersome, like how much typing you have to do. But basically, if you need it for whatever reason, so let's just reuse our reference. So now I've given myself a default value. So when this thing gets called, it's going to use these definitions. Now, in the case of this, nothing's happening. So why is that? So it turns out that that environment variables don't actually manage the state, meaning they don't trigger a body re-render. So you still have to use an observed object or a state object in order to do the actual trigger for the modification. So if So as long as I'm able to trigger the re-render, the change of its variable is going to show up. To be honest, I'm not sure how useful this thing is, other than, again, to use the built-in variables for the system, things like layout and horizontal sizing and stuff like that. I don't see myself using this that much, and it is cumbersome to write out at the same time. Although I wouldn't say the lack of tie-in to the UI is necessarily an issue, because you may not necessarily even want that anyway. But anyway, this is available for you to use as an option on top of everything else. Okay, so in React there's something called local storage. So local storage allows you to make permanent key value pair entries that you can reuse later, even after your application has shut down. Now, this is part of JavaScript, it's not part of React, so there's no tie-in to the view system, so changes there don't trigger a re-render, but nevertheless, permanent storage capability is there. So in SwiftUI, there is something called user defaults where you can do this permanent storage, but again, that has no direct tie to the UI system. So in SwiftUI 2.0, they created something called app storage. And app storage allows you to write to user defaults, but at the same time to be tied to the UI. So when you make a change to user defaults, it causes a re-render. So what this looks like is it's basically a key value pair. If this key has never been set, it will be set. If it has been set before, this setting will not happen. Okay, and so this is something important to remember. And I've taken the liberty of creating this guy. He is the screen that should load if the user has never loaded the screen previously. And we can just copy and paste this also into here. Again, it doesn't matter which screen touched this. If it has been set before, then it's not going to be reset. Okay, so if we come here and we say, all right, was onboarding done yet? Okay, it was done. So then I'm just going to show the regular screen. If it was not done, then I want to show the onboarding screen. In the onboarding screen, we should have some way of acknowledging that onboarding was done so that we can go to our normal screen, which is the one that we were working on before. So as you can see, the app loads, the scene loads via body, then it decides, okay, which screen do I need to load? And then since it's never been set before, it decides to load onboarding view. Then if I say I'm done with the onboarding, then it will go to the regular screen. And as I said before, user defaults, which is what this is wrapping, is still available to write directly, but it will not cause a re-render. So this, again, like most of the other property wrappers, is just a shortcut that gives you this functionality built in. Okay, so that's it. There's actually another SwiftUI 2.0 property wrapper called Scene Storage, which is similar to App Storage, but it's specific to different views. I'm not going to cover that here. This video is running a little long, and that property wrapper seems to be more, edge case specific. So I'm just going to end it here. Thanks.